Yeah, okay. I'm recording now, so okay. I'm okay. I'm recording already. Bismillah ar-Rahman ar-Rahim. Yes, chapter 1. First, I want you to know two words. The two words are accuracy and precision. Accuracy and precision. If a student is throwing these pieces of papers in the pen, like in the case of A, the student is both accurate and precise. This student is neither accurate nor precise. All right. How about the student? What do you think about the middle student, B?
Precise, but
Precise,
Precise.
not accurate.
But
not accurate.
not accurate. Because he's always throwing at the same place. So he's precise, but not accurate. Okay, let's have this example. If the answer is 0.370 is the correct answer. 0.370 is the correct answer. All right. Then, is student A correct or precise or none of them? Student A.
Neither.
No.
Precise.
Precise only.
Precise, not accurate. How about student B?
Neither.
Neither.
How about student C?
Accurate and precise.
Yes, accurate and I hope you know this. Good. All right. Dimensional analysis. Very important word I want you to use in the solving problems in general. You remember the table I gave you, which is the conversion of meters or anything into higher value. This table.
Right.
I told you to memorize it. Did you memorize it?
Yes.
I want you to memorize it extremely well. Extremely well. All right? Why? I want you now to use dimensional analysis. If I know that, for example, 1 meter is equal to how many nanometers?
1 multiplied by 10 to the power 9.
The power 9.
Plus nanometer. Very good. How about 1 meter equal to how many kilometer?
-3.
-3.
Minus 3 kilometers. All right. When you have this equality, then you can write them in fraction. I can write 1 meter over 1 times 10 to the power 9 nanometer. Or I can write 1 times 10 to the power 9 nanometer divided by 1 meter. Okay. Also, I can write this one 1 meter divided by 1 times 10 to the power minus 3 kilometer, or I can write 1 times 10 to the power minus 3 kilometer over 1 meter. Why? If they are equal, I can make them not as equal, but I can make them in fraction. Can you see that? Okay, good. Now, if I ask you, if I have 3.72 kilometers, how many nanometers this? How many nanometers?
Can't tell you right away.
10 to the power of 2 meter.
10 to the power.
Use the conversion factor, conversion factor or the fraction method to get rid of the units. This means I will use this part, which is 1 meter divided by 1 times 10 to the power minus 3 kilometer. This way, I will get rid of kilometer with kilometer. And then I want to get rid of millimeter, meter, and I will want the answer in nanometer. So I will use which conversion? Conversion 1 or conversion 2?
2.
2. I will put 1 meter here deliberately to get rid of meter with meter, and then this will be times 10 to the power 9 nanometer. And you can see here, I got rid of all the units except nanometer, and then tell me what's the answer now, which is going to be 3.72 times 10 to the power, what?
12.
12.
Minus.
No, plus 12.
Plus 12, yeah.
12 nanometer. Yes. This is called conversion factor. Whenever I give you, of course, this you should memorize yourself, but sometimes I will give you equalities and I want you to convert things easily. For example, if I say here 1 inch equal to 3.54 centimeter. Okay, you have to keep this in mind. You have this already. Now, I will also tell you that, let's say that 1 foot is equal to 12 inch. Clear? And 1 meter, of course, is equal to how many centimeters?
100.
100.
Or 1 times 10 to the power 2 centimeter. All right, good. Next, let's assume that I have 6.31 foot. Then how many meters is this? How can I find the number of meters? What's the first step?
Convert to inches. Convert to inches.
What should I write at the top or the bottom?
On the top.
The top is 12 inches.
12 over 1.
Down?
1 feet.
1 foot. Okay, good. And then?
Convert to
down.
centimeter.
Centimeter.
To
Centimeters.
Inch to centimeter. So which conversion should I use?
Centimeter up.
2.54 centimeter over 1 inch.
Okay, and then what's the next step?
Convert
From
to
centimeter to meter.
Which is what? What should I write at the top?
1
1
over
meter
power.
over 100.
100.
And then you get rid of the unit with the unit with the unit, and you have the answer. Is this clear? Now, the conversion factor are all exact. So this is exact number. This is considered to be exact number. This is exact number. This is exact number. This is exact number. How many significant figures should I have at the end?
0.
3.
3.
The exact.
Unlimited.
No,
Three.
It doesn't matter.
Exact number.
three significant figures. And that's why I care about only this one. I don't care about the rest. So what's the answer should be? Give me an answer. I mean, do it in your calculator and give me what should I write.
Three significant figure.
Give me the answer.
1.92.
1.92 meter. See, I converted foot to meter without thinking, should I divide or multiply? No, get rid of units. Get rid of units. Is this clear? Very good. And don't
Yes.
worry about the significant figures in all these figures. All these figures, don't worry about the significant figures in this one. The significant figures is only in the number that you're dealing with.
So, Doctor, if we have 0.12 multiplied by 10 with the power of 12, we only have two significant figures?
Yeah.
Okay, thank you.
Okay, let's solve this problem very quickly. All right. We have here two equalities. Look at this equality. This one equal this one. This one equal to this one. All right. Now, how many AU atoms? I want this one. How many AU atoms are available in 5.27 gram AU? And this one, that's what I have here. Always start with whatever is given to you. 5.27 gram AU. Then, how many, what should I, how can I solve this problem? I want to know how many atoms.
One mole over.
1 mole
Here,
over 196.
mole over what?
196.900.97.
1 mole AU divide by what?
109.
I get it this unit within it. Am I done?
No.
No.
Step.
Multiply by 6.022.
6.022 times 10 to the power 23. Oh, sorry. This should be power. I wrote it wrong. This should be 10 to the power 23. Okay. Atoms. AU divide by what?
One mole.
One mole.
One mole.
Mole AU. The mole AU will go with mole AU, and you have the answer. Use your calculator and give me the answer.
1.61 times 10 to the power 22.
1.61 times 10 to the power
22.
22 atom AU. See, we are using the conversion factor, using conversion units, using of dimension analysis method to solve a problem. This problem, you will get it in chapter 3. So I'm giving you a problem from chapter 3. You don't know what's the meaning of mole at this time and the meaning of this number, which is Avogadro's number, but you are solving a problem using conversion factor. You have to learn how to use conversion factor or dimensional analysis, and you should be able to solve problems sometimes without knowing what's going on. Is this clear?
Clear though.
This is extremely important method to solve problems. You have to know how to use this method, which is called dimensional analysis, to solve problems like this. Very good. With this, we finished chapter 2, chapter 1, yes?
Is the AU atom considered as exact number?
At this time, no. But don't worry about these things at this time for this example, because this will take it in chapter 3.
Okay.
Okay, good. All right, good. Next, we finish chapter 1, and right away we'll start chapter 2. All right, good. Chapter 2. What's the title of chapter 2?
Atoms.
Atoms, molecules, ions.
Ions. We're going to define atoms, what are molecules, and what are ions. And they want you to answer me. What are the, do you have the periodic table with you?
Yes.
I told you
Yes, I have.
the periodic table with you to every lecture. Where are the atoms in the periodic table?
In the boxes.
The atoms in the periodic table.
In the boxes.
In the boxes.
Everything in the periodic table is an atom. Whenever you see a square like this, inside the square, what's this?
Hydrogen.
Hydrogen. What's this?
Helium.
Helium.
Helium. What is this?
Lithium.
Lithium.
This.
Beryllium.
Beryllium.
Helium. What's this? Boron.
Boron.
Nitrogen.
Carbon.
Nitrogen.
Oxygen. Chlorine. What else? Neon.
Neon.
These called what? Atoms. All right. These are called atoms. Okay. What are the molecules?
2 atoms or more.
CO2.
Or more. Not only 2 atoms. If they are the same, then they are part of the atoms. Like O2. Is this considered to be molecule or atom?
Molecule.
Molecule.
Molecular atom. Molecular atom. Molecular atom. But let's have molecules. Give me example of molecules.
H2O,
H2O. What else?
CO3,
CO2. Not CO3. CO2. What else?
CH4.
CH4. Very good. NO2. N2O5. What's the property?
NH3.
HCl.
What's the property of the molecules? It's 2 or more atoms. Good. What is the ions?
NaCl.
Electrified atom.
Positive
Gain.
You have electric charge.
and negative.
Ions.
Give me example of positive ion.
Lithium.
A plus.
Lithium. Aluminium plus 3. Lithium. Cesium.
Negative ion. Negative ion.
Fluor. Chlor. Carbon.
Minus.
Oxygen.
O2 minus.
Beryllium.
Calcium 2 plus. What's the meaning of positive ion?
Leave
Ion with the
electron or
Losing electron. Losing electron.
What happened to the atom?
Losing electron.
Lose electron. What's about the negative ion?
It gains electrons.
gain electron.
Gain electron. Very good. You have to know this. Very good. Now,
Doctor,
yes.
what's the difference between the atoms and the elements?
The atoms and the elements, they are the same. The elements are consisting of atoms. Exactly.
Okay, clear.
All the elements are consisting of atoms. Okay, we're going to talk now about how the atom was found or how the molecules are found and so on. And we're going to talk about the atomic theory. The first theory we're going to talk about is Dalton theory. And I want you to memorize the name of the scientist. What's the name of the scientist?
Dalton.
Dalton. Atomic theory. Dalton atomic theory. And he is considered to be the first one who proposed the atomic theory. The name is Dalton. Memorize the name, Dalton. Okay, good. What is he saying? That elements are consisting of small particles, extremely small particles. These are called atoms. So he's saying that all the elements are consisting of atoms. Okay, and the second theory, which of course we know this. Okay, now atoms of the same element have this, atoms of the same element are what? The same.
Same.
Atoms of the same element are the same. They have the same size, they have the same mass, they have the same chemical properties. Atoms of different elements are different. Clear? This means if I have hydrogen, what's the atom of the hydrogen? H. What's the other atom of the hydrogen? It will be also H. It will be H for everything. But if I have chlorine, then what's the atom for chlorine?
Cl.
Cl.
What's the other atom?
Cl.
Cl. What's the other third atom? Cl. Atoms of the same element are the same. They have the same properties. They have the same structure. How about atoms of different element? Different.
They are different.
So they are the same for chlorine. Okay. Of course, this one is something clear for us now. At their time, it wasn't clear. He proposed this. Okay, good. Now, compounds are consisting of what? How can we make compounds?
Two or more.
Two or more elements.
Atoms of more than one element. More than one element. Example, H2O. Atoms, this is the atom of hydrogen, this is the atom of oxygen. They combine together to make the compound. That's the proposal he has. Good. What's the third thing? Chemical reaction. What is the chemical reaction?
تفاعل.
Chemical reaction are exchange of atoms. This means here we have two atoms, hydrogen with hydrogen, and here we have oxygen with oxygen. What's a chemical reaction? It's exchange of atoms. See, they exchange the atoms together, and we need to balance it. So we have to balance it like this. This is now how the chemical reaction takes place. So what is the definition of chemical reaction by Dalton?
Rearranging atoms.
Rearranging atoms in chemical compounds.
Or exchange of atoms. Exchange or rearrange of atoms. Good. Now, there are theories which are important. First of all, there is a theory called law of conservation of mass. What's the law of conservation of mass? Do you know what's the law of conservation of mass?
Mass of reactant equals to mass of product.
Exactly, that's exactly, but this is too advanced. You cannot lose or gain mass. All right, when you make a chemical reaction, the mass of the product, the total mass of the reactant must equal to the total mass of the product. This is the law of conservation of mass. Good? Good. Next. Law of definite proportion. Law of definite proportion. What is this law? This law says that when you have two atoms combined together, like carbon and oxygen, they combine together, they will make one compound. What's this compound? Let's say it is CO. All right. Then the theory says law of definite proportion. The ratio of the mass of carbon compared to the mass of oxygen must be always the same ratio. What do I mean? What's the mass of carbon in your periodic table? Look at the periodic table. What's the mass of carbon?
12.37.
12.01. What's the mass of oxygen?
16.
16.
16.0. Okay. Now divide by the smallest. Divide by 12.01. What are we going to get here?
1.33.
1, 2,
3,
0.33.
Yeah.
Is this clear? So this is called the law of definite proportion. The law of definite proportion says that the mass of one element to the mass of the second element in the same compound must be always the same. Okay, good. Let's assume we have, okay, good. We have CO2. Then what's the ratio of C to O in CO2? Not in CO, but in CO2.
1 to 2.6.
12,
38.
Put here 2.01 compared to what?
32.
32.
16.00, which is 32. Divide by 12.01. Then what are you going to get? 1 compared to what?
2.66.
2.66.
66. Exactly. Can you do the definite proportion for anything now?
Yes.
Okay.
Yes.
Okay. Do it for NO2.
It's 2.28.
It's 14.01 to 2 times 16, which is what? Divide by 14, then this will be 1, and this will be what?
2.28.
2.28.
1.8?
28.
2.8. Very good. I did not do it, so you did it. Okay, is this clear? What's this law called?
Law of definite proportion.
Definite proportion.
Proportion, law of definite proportion. To us here, it was easy. At their time, it was very difficult. They discovered this by experiments. That's what they have. This is the mass of oxygen compared to the mass of carbon, and this is the ratio. This is the mass of in another compound. This is the mass of oxygen. This is the mass of carbon, and this is the ratio. And this is the mass of oxygen. This is the mass of carbon. This is the ratio. They discovered this at that time. Now for us, it's very easy. We can get it from the periodic table. Is this clear?
Doctor,
Yes.
we always compare the one of the bigger mass over.
Not necessarily. No, you don't have to. If you want, you can do it otherwise. You can do what's the if somebody says what's the in CO, for example. If this is 1, what will be the carbon in this case?
The reciprocal.
Give me the number. What will be the ratio if we have CO compound?
1.33.
No.
Divide by.
What will be the ratio of oxygen to carbon?
0.75.
0.75.
0.75, exactly. Let's see. Right.
Doctor.
It is 1.752 if you want to be exact. Yes.
If the ratio changes, that means the compound changes.
If you the same compound and the same CO, for example.
Yes, if the ratio changes.
Leonard, you can never have different ratio in the same compound. You can never have that. This will be always 1 to 1.33, or it will be 1 to 0.752.
751 though.
1 2. Yes.
Doctor,
Yes.
how can I define the mass of oxygen alone and carbon alone? If I have like the sample 123, how can I say that it's 89.4 oxygen and 33.6?
Now, this is now, let's assume, use this method now, or let's do it for CO. If the mass of, if we have CO, I'll come back to CO one more time. We said that the ratio of carbon to CO in CO is 1 to what? 1.33. Clear? You agree? Good. Now, let's assume that I have CO compound and I found the mass of carbon to be 2.7 gram carbon. Then how many grams of oxygen must be in the compound?
2.7 times 1.3.
I wanted to use conversion factor.
3.591.
I wanted to use conversion factor. You should write 1.33 gram O divided by what?
Divide by 1
Gram carbon. What will happen to gram C with gram C? Will go away and you have the answer. So if I have 2.7 gram carbon, how many grams of oxygen I'm going to have?
3.6.
Okay, 3.6. Is this clear?
Yes.
Yes.
Okay, law of definite proportion. What is the ratio of S to O in SO2? Come on, give me the answer.
1 to 1.
1 to 1.
1.
All right, very good. How about in another compound, which is S2O and SO3?
1 to 1.3.
1 to 1.5.
1 to 1.5.
1 to 1.5. Is this clear? So in different compounds, we're going to have different amount of oxygen compared to sulfur. You should know this, and you should keep this in mind. Now,
Doctor,
yes.
can you explain how you get 1 to 1 in SO2?
You have periodic table?
Yes.
Okay. What's the mass of sulfur?
32.
Point?
0.06.
0.06. Okay. How about oxygen?
16.
16 times 2 because it's O2.
Yes.
What is it?
Oh, 1 to 1.
Clear?
Yes.
Okay, I hope so. Good. Now, I want you to concentrate now with me. Now, if you look at this one and this one, what's it? And now these are two different compounds. SO2 is different than SO3. These are two different compounds. Is this clear? Now, I will give you another theory, which is called the law of multiple proportion. Multiple proportion. Let's have it in this one. Okay. Law of multiple proportion. C combined with O2 to make CO, and carbon also combined with O2 to make CO2. Of course. All right. And if you want to, we don't have to balance it. Don't worry about the balancing. Is CO and CO2 are the same compound?
No.
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 Nope.
Yes.
No, of course
What's the
not.
property of CO2?
Gas, maybe.
They are both gas, of course.
Yes.
But if
The
we,
physical property.
when we breathe, we take in our oxygen in our body, and we give out what?
The carbon.
The
CO2.
CO2.
CO2 comes out of when we breathe. When you breathe, you're breathing O2 and exhaling CO2. You are exhale CO2. Okay. How about if you breathe CO? What will happen?
I think it is poison.
It's
Poison.
kill you right
It's
away.
poisoned.
If you
Right.
breathe CO, you will be killed. So these are completely different compounds. Is this clear? Even though they are made from the same atoms, from carbon and oxygen, from carbon and oxygen. But this one is, we're using it, plants are using it to make oxygen out of it. And this one is very dangerous for us and even for plants. Even the plant, if it takes CO, it will die right away. Is this clear? Good.
Yes.
Now, these two compounds, when they combine, they are two different compounds, but there is relation which we are going to talk about it, which is law of multiple proportion. Law of multiple proportion. What do I mean by that? When two elements combine together, C combine with O2 to make two different compounds. One is called CO, and the other one is called CO2. If you take the ratio of CO, the definite proportion of CO, what is it?
1.33.
1.33.
And if you take for CO2, what is it? 1 to what?
266.
2.66. They noticed that if you take these two numbers and put them together, 1.33 compared to 2.66, this is equal to what?
Half.
1 over 2. The ratio must be simple. Okay, that is the law of multiple proportion. What's the multiple proportion says? That if you have two elements combined together to make two different compounds, then if you take the definite proportion for this one and definite proportion for this one, or the amount that will react with 1 gram of this one compared to the amount that will combine with 1 gram of this one, must be simple ratio 1 to 2. 1 to 2. Let's do it for this example. S is reacting with O2 to make SO2 and SO3. Now, let's do the definite proportion. What's the ratio here? 1 to 1.
1 to 1.
1 to 1.
1. How about this one?
To 1.5.
1.5. Now, let's do the multiple proportion. If you take the amount of O2 that will react with 1 gram, if this is gram and gram, everything is gram. If you take the amount of oxygen that will react with 1 gram compared to the amount of oxygen that will react with 1 gram of this one, what will be the ratio?
2 over 3.
2 over 3.
2 over 3.
2.
This is equal to 2 over 3. Now, I want you to notice another thing. Do you see the 2 and 3? Do you see them in these compounds?
Yes.
How do you see them?
The number of atoms.
The oxygen.
So, it's this one. So they discovered that when you have more than one compound, we can discover from the amount of oxygen how much, what will be this ratio here? It is 2 to 3. Okay, in CO2.
It's only for SO compound.
No, for any compound that consists of two elements, which is sulfur and oxygen.
Also the CO.
CO, what was the ratio?
1/2.
Do you see them in this compound, these two compounds?
Yes.
Where do you see them?
O1 and O2.
1 and 2. This is the 1 and the 2. Okay? Okay. Let me give you an example. If I give you these two compounds in let me give you a more difficult question now. If I have these two compounds, what do you expect the amount of oxygen that will react with nitrogen in this case? What will be the ratio, you think?
3/5.
No,
6
not 3/5.
6/5.
Yes.
2.5.
2/5, which is 6/5. Is this clear? Why? Because this is N2. What did I do? I made this N2O6. Now I can compare. And the ratio will be 6/5. It's clear.
Yes. I have a question.
You repeat that?
One more time. I will repeat it. No problem. Let's erase something. If I have two compounds, I will give you another example. Okay, let's assume that we have N2O5 compared to NO2. Another example. Anyway, what will be the ratio of oxygen to oxygen in the second example?
5/4.
5/4. Why? Because you need to make this equal. So I'll change this to N2O4, and then I compare these together like this. Okay. So what's the ratio? Says that the amount we can make everything in gram. What's the law of multiple proportion? If you take the amount of one element that will react with 1 gram of sulfur of any other the other element compared to the amount of element that will react with 1 gram of the other element, these two numbers must be simple ratio. This is called the law of multiple proportion. I hope it's also clear. Good. Next, let's have these two examples. Okay, we have H2O. What's this? Water. Compared to H2O2. Okay, what's this?
Hydrogen peroxide.
Hydrogen peroxide. Okay, H2O compared to H2O2. And let's solve this example. When water decomposes into component, it produces 1.125 gram to every 1 gram oxygen. Okay, how about in this one? In hydrogen peroxide, it's 0.063 compared to 1 gram oxygen. So what will be the simple ratio for these two?
1/2.
You have to take these two numbers and divide them by each other. That's all. So it's going to be 0.25 compared to what? 0.03.
1 to 2.
What's the issue?
Half.
2 over 1.
2 over 1. 2 over 1.
Doctor, how can I know which one should I put up and down?
No problem. It's if you put them upside down, then it is 1 over 2. This one to this one. So you are comparing now. This one is related to the first one, and this one is related to, I'll call it A, and compare to B. So you're comparing here this one, which is A to B. If you write it B to A, what will be the ratio?
1 over 2.
1 over 2. And both answer is correct. Is this clear?
Yes.
Were you expecting the ratio to be 1 to 2?
Yes.
Yes.
How?
By multiplying the first
This one by
water molecule.
then
2.
what is the ratio in this case?
1 to 2.
4 to 2 or 2 to 1, which is, you can get it from the structure as well. Is this clear? I hope so.
Oh, Doctor,
yes.
Why would we multiply? It's the same number, 2 and 2.
Yeah. Oh, okay. No, it was 1 to 2. It was H2O only.
We're talking about hydrogen.
The base is oxygen.
But you
use it to compare.
You need to compare it to oxygen. Okay. It was like
the oxygen. Okay.
It was like this: H2O2 and H2O. I want to compare. Should I say 2 to 2? No, I need to make also the oxygen the same because I'm comparing to oxygen. So what should I do? I should
multiply
2 this way. This will be 4. Is this clear? Now it's 4 to 2 or 2 to 4, the same thing. 2 to 4, 1 to 2. Okay, I hope this is clear. Let's finish with this one. Let's go now to the next subject, the discovery of the elements. The discovery of the elements. How people at the beginning thought that each element or each atom is solid ball like this, and it is solid. Like this, like ball. They think any atom is like this. Solid ball. Think about any ball, but it's solid also from inside. Okay, that's what they think. Until a scientist came, his name was Thomson. You have to memorize the name. J. Thomson. Thomson. Okay, it is available in. It's not here. Okay, you have to memorize the name, Thomson. What did he do? He had this experiment. Okay, he had a plate here of gold and another plate of gold here. He connected by electricity and he put it in a tube like this, which is completely empty. Completely empty. Then he put electricity on the tube. This is connected to electricity from this side and this side. Like this is the electricity. See, this is cathode and this is the anode in here. This is the anode. And the anode and the cathode are connected to electricity like this. All right. And then he found that there is something coming out of this tube toward this toward the other thing. Even though the tube is empty, the tube is evacuated. What's evacuated means?
Empty.
Nothing.
Empty.
No air at all. No air inside. So there was nothing in here. But he found that something is coming, and he noticed when he put the magnet like this, if this is the positive magnet, what happened to this thing that's moving?
Coming closer.
So what will be the charge of the green thing?
Negative.
Negative, minus. Clear? This is called cathode ray experiment. You must memorize the name. What's the name?
Cathode ray experiment.
Cathode ray experiment. Cathode ray experiment. Who did this experiment?
J.J. Thomson.
Memorize these things. J. Thomson or J.J. Thomson or Thomson. Thomson is good enough. What did he do? He put a tube which was evacuated. What's evacuated means?
Nothing is inside.
No air.
No air.
And what did he found? That something is moving. And what's the charge of the thing that it was moving?
Negative.
And he called them, what did he call them?
Electron.
Electrons. And he signed them with E. Electrons. All right? And he was able to calculate the charge to the mass of the electron. Charge to mass. Is this clear? So let's repeat one more time. What's the name of the experiment?
Cathode ray experiment.
Who did it?
J.J. Thomson.
J.J. Thomson.
What did he discover? That there is what?
Electrons are negative.
What? And these electrons are negative. Yes, excellent. And then what did we calculate?
The
mass of the electron. Charge to mass.
He did not calculate the mass of the electron. He calculated charge to mass of electron. He calculated charge to mass. Charge of the electron to the mass of the electron. All right, clear?
Please.
Next, another experiment. You must memorize the name. The scientist called Millikan. Millikan. You must memorize. What's the name of this experiment? It's called oil drop experiment. Experiment. Oil drop. You must memorize the name. Oil drop experiment. Okay. What did he do? He have a room like this, and he have some things like this, moving particles, and he was able to notice them by, he hit them with X-ray, and by hitting them with X-ray, he found that there is some particles will not move at all. He was watching this experiment by microscope, and by hitting them with X-ray, there was charges in the particles. He was able from this experiment to calculate the charge of the electron. E, charge of electron. So that's what I wanted to answer me now. What's the name of the scientist?
Millikan.
What's the name of the experiment?
Oil
drop experiment. Okay. What was he able to find?
The charge of electron.
Charge of electron, which is E. Okay. All right. Then from the charge of the electron, then came what was Thomson discovered?
The ratio between the charge and mass.
The charge to mass.
Charge to mass. This is Thomson. Okay, and then this is Millikan on the chart. What can you calculate?
The mass.
The mass.
Mass. E divided by E over M will give you mass of electron. So these two scientists were able to find the mass and the charge of the electron. The mass and the charge of the electron. Is this clear?
Yes.
Yes.
Doctor, do we need to memorize the mass and charge?
No, the numbers we don't have. You have to know this ratio. You have to know what's the ratio that was discovered by Thomson. And you have to know what is Millikan discovered. That's all.
Doctor.
Yes.
If we ask who discovered the mass.
Both of them.
Both of them.
Yeah, but actually, if you want only the mass, then it is Millikan.
The mass Millikan.
If you want to say, I want to know exactly the mass, then it's Millikan. Even the charge, the exact charge was discovered by Millikan. But what did Thomson discover?
The ratio between them.
The ratio between charge and mass.
Okay.
Okay, good. So this is the discovery of Thomson, which is the charge to mass. And as I said, don't memorize the number, but you have to know this is, what does this number represent?
Charge to mass.
Charge
to mass. And that's why the units are Coulomb to gram. Coulomb to gram. All right. And then Millikan was able to find what?
The charge of the
charge.
Charge. And then by C, how can you find the mass? Divide this number by this number. Or vice versa, sorry. Divide this number by this number here, and you have the mass of electron. So this is the mass of the electron. Don't memorize it, but find, just know it. Just keep it in your mind. Okay, then another big work was done by Mr. and Mrs. Curie. Curie was dealing with uranium, and they found that uranium, if you keep uranium by itself, it will give you radiation. There will be radiation coming out of radium, which is called alpha particles, alpha rays, gamma ray, and beta ray. That was discovered by, what's the name of scientist?
Curie.
Marie Curie.
It's actually Mr. and Mrs. Curie, but Mr. died early, so the most famous now is Mrs. Curie, who discovered this thing. But they were working together. They are husband and wife, but the man died early and the woman continue and this discovery. Okay, what's this discovery? That uranium element, when it decomposes, it will give you 3 particles. What are these 3 particles?
Alpha, gamma, beta,
and gamma. The charge of alpha. What's the charge of alpha?
Positive.
Negative.
Positive.
Positive 2.
And what's the charge of beta?
Negative.
-1.
Charge of gamma?
No charge.
No charge.
Actually, alpha was found to be helium atom without electrons. It's He. So alpha is helium atom, but no electrons. That's why it is helium 2+. And beta is actually electrons, just simply electrons with a negative charge. You have to know this. So, and gamma is radiation. So what is alpha?
Helium.
Helium without
Helium without
minus
Helium
And what's beta?
Electron.
Just
electron.
electron.
Radiation.
Radiation. Okay. Next, another important name you must memorize: Rutherford. Rutherford. Rutherford did the experiment which is known as Goldfold experiment. This is the name of the experiment. What's the name of the experiment?
Goldfold experiment.
Foil
experiment.
Gold foil experiment, which is sheet. Foil means sheet. Okay. Gold foil experiment. What did he do? He took a piece of gold like this one. This is gold, just simply gold. And he hit it with what?
Alpha.
Particles.
Alpha ray.
Alpha, which is this radiation, alpha. Okay? He was expecting that all the alpha particles will go through like this. But no, what happened? He found that some will go through, but some will be reflected, and some will even be deflected maybe. It will come back like this. So he was expecting, before doing the experiment, that all the rays will go through like this. This is expecting, maybe. But what did he find? Is this true?
No.
What did he find? That it will be reflected or deflected. Some rays will be deflected or reflected. Deflected means goes aside like this, and deflected or reflected means come back like this. Is this clear? So deflected is the ray comes like this and deflected like this, and reflected means the ray comes like this and then return like this. Okay? And he said the reason for that is because the atom is completely empty, and there is the nucleus. He called this now, what did he call him? Nucleus.
Nucleus.
We called Nawah. And the electrons are around it, like this. And he said that this is how the atom. Okay, what's the name of the scientist?
Rutherford.
Rutherford. What's the name of the experiment?
Proton in the nucleus.
What's the name of the experiment?
Gold foil experiment.
What did he discover? That the atom is?
The atom is have nucleus.
Have nucleus and the
electron around.
Electron is around.
What's inside?
Empty.
Empty space.
Exactly. This is the discovery of Rutherford. All right. Then you notice, I mean, it's clear. Is it clear? Okay. So, yes. So don't forget the names are important. Even the names, Rutherford. Now, what did Rutherford say? That atoms are consisting of what?
Nucleus.
Nucleus. And the nucleus is inside, and the electrons are where?
Around the nucleus.
And there is empty space in between. Okay? Then another scientist, you must memorize the name. Mostly student of Rutherford. He was working with Rutherford. Okay? Student of Rutherford mostly discovered that inside the nucleus there is something called protons, which is positive charge particles. Then another scientist called Chadwick. You must memorize all these names. Discover that there is also another particle in the nucleus. It's called what?
Neutrons.
No charge.
Which is no charge. So 3 names, very important names. Rutherford discovered that there is what? Nucleus. Then come his student. What's his student name? Mosley. Yes, and what did he discover?
Protons.
And they are what? Positively charged.
Positive charge.
This was the name of the scientist.
Chadwick.
That there is neutrons and it has no charge. Is this clear?
Neutral.
Good.
Yes.
So from this, that's the name of Chadwick, by the way. This is Chadwick. Okay. From this, we found that this is the shape of the atom. There is a nucleus. What's this called?
Nucleus.
What's in the nucleus?
Proton and neutron.
Protons and neutrons. There, if we enlarge the nucleus, this is the nucleus. This is called protons. We're going to present it by which letter? P. What's the neutrons? N. And outside, they are what? Outside.
Electrons.
Electrons.
Negative.
Around E. What's the charge?
Negative.
Negative electron.
What's the charge of protons?
Positive.
Positively charged.
Okay.
No charge.
Of course. Do we know what's the mass of the electron?
Yes.
How did we know it?
American.
By mass.
Yeah.
So the charge and the mass of the electron, the protons, and the neutron was found together. And this is the, don't memorize these numbers, but this is the mass of the electron, this is the mass of protons, and this is the mass of the neutrons. Okay, and we know that the charge of electron is what?
Negative.
And the charge of the proton?
Positive.
And the charge of neutron?
No charge.
Zero. Okay, now I will make another table, this table in gram. All right, now I will make another table. I will write E, P, and N, and I will write the mass, and I will write the charge of electron. And we know the charge is what? For electron, it is what? Minus 1. Proton?
Positive 1.
Plus 1. And for neutron?
No
0.
charge.
Okay. For the mass, I will use another unit, which is called AMU. which is called AMU. What's AMU stand for?
Atomic mass unit.
Atomic mass unit.
Mass unit. Atomic mass unit. And in this case, I will say for proton it is 1, for neutrons it is 1 AMU, and proton it's AMU, 1 AMU, and for E it's small and they will consider to be 0 AMU. Clear? I want you now, this minute, it's very easy to memorize this table extremely well. Did you memorize it?
Yes.
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 Do you see here? What's the mass proton?
1 AMU.
What's
One.
the mass neutron?
1 AMU.
1 AMU.
Because they are approximate. But look at the mass in gram. Look at the mass. Are they close? 1.67 to 1.674. So they are, if you take significant figures, they are be almost the same. Is this clear?
Yes.
Very good. Now, if I give you any atom, like for example, hydrogen, and sorry, I will make two definitions before we go further. Okay, I want to make atomic number Z. What's atomic number Z?
Number of protons.
Number of
Number of protons. That's it. What is mass number A?
Neutrons
and neutrons.
You have to memorize this. Z is equal to number of protons, and then atomic number is number of protons plus neutrons. Usually when we write any atom, we will write it like this. Like for example, hydrogen, we write at the bottom Z, and we write at the top A, which is atomic number. Okay? And if there is no charge, we don't put anything. But if there is charge, then we will put it like this. Let's talk about still hydrogen. All right? And then we'll put, for example, plus. If I put it like this, now I will write everything in numbers. If I write H, 1, 1, and 0, then in this element, how many protons?
1.
Equal to 1. How many neutrons?
0.
0.
Ah, 0. Why?
Because the mass number 1.
The mass number is 1.
Exactly. What's the number of electrons?
1.
1.
There is no charge. The number of protons must equal the number of electrons. How about if I put, how about in this case, again, H, I will write something else now. H, 1, 1, and plus 1. How many protons?
1.
Neutrons?
0.
0.
How many electrons?
0.
Why? Because I lost 1 electron. Is this clear?
Yes.
Good. Let's have some more examples.
Doctor.
That we have Cl 1735 minus. Then how many protons do you have?
17.
17.
How many neutrons?
18.
18, yeah.
18. How many electrons?
18.
18.
Good. Let's do something else. Let's say we have 4, 5, 11.
Doctor,
Yes,
did you open the attendance?
not yet. Okay, 5, 11, minus 3, minus 2, minus 2, let's say. Okay, then how many protons? Quickly.
5.
5. How many neutrons?
6.
6.
How many electrons?
7.
7. Why? Because 5 plus 2. Exactly. Good. All right. When we can have elements. What's the difference between these three elements? Hydrogen, hydrogen, hydrogen. They have the same number of what?
Number of
protons.
Of protons.
Neutron, different neutron.
Protons.
Number of neutrons. How many neutrons do you have here?
2.
0.
0, 1, 2.
1.
Here. How about here? How many neutrons?
1.
1.
How many neutrons here?
2.
2.
These are called isotopes. So what's the definition of isotopes?
They have the same number
Same
of
atoms,
protons,
but different neutrons.
Right. All right. With this, we finish this part. Okay. Let's go very quickly to attendance, please.
The class finished 4 minutes ago.
Oh, I'm sorry for that.
Doctor, is the homework available now?
Not yet. I will put it today. And now I will announce about it and I will send it to you, inshallah.
Doctor, can you send the link?
I will send it right this second. Okay, go ahead. It's open now.
Can you send the link, please?
I sent the link. Look at the chat. It is available there.
Teacher,
Yes.
I come to the class with the outer link because you didn't add me to the teams. I just add the course last week. So I don't have a shot here. And I can't see the link.
What is your name? I think I can send you the link.
Abdullah Ali Garni.
If you have the link on the team, Abdul Garni.
No, I don't have it. Okay, he sent me Muhammad.
Okay.
I sent you also the link.
So
Okay, thank you.
to the attendance sheet and use the KPPM mail.
Can we leave, Doctor, now?
Yeah, that's done.
Thank you.
I'm done. Thank you.
Okay, I did it. But can you add me to the teams?
Inshallah, I will add you. No problem. Just send me by WhatsApp your name and I will add you to this.
Okay, thank you.
By WhatsApp, send me your name and your ID.
Okay.
دكتور. دكتور.
نعم، السلام عليكم.
السلام ورحمة الله. عندي سؤال.
ايوه اعطني 10 دقائق بريك وبرجع لكم الان ان شاء الله.
طيب تمام.